variance of a discrete random variable. So this is lesson 6. So for this lesson, you're expected to identify the mean and variance of a discrete random variable and illustrate the mean and variance of a discrete random variable. So first we will have to unlock the terms, unlocking of term. So you have there the word average. So I know you're familiar with this word. The word is average. What are the synonyms of the average? What does it mean when we say average? So average means it's the central value or the middle value. So for example, Anna's first quarter grades in 10 subjects are the following. So we have the grades of Anna for the first quarter are the following: 90, 92, 95, 95, 96, 93, 93, 95, 94, 94. So I know you are all familiar with your average. How do you get the average grade? So we simply add the scores, the grades, and divide it by 10. So in doing that, the average of Anna for the first quarter, the average grade is 93 and 7/10 or 93.7, or approximately equal to 94. So what does 93.7 means, or 94? So this is the middle grade. This represents the 10 grades, yet the grades in 10 subjects. So you might say that she is performing very well because she has an average grade of 94 or 93.7 or 94. So this 94 is the middle of the grades, the middle of the 10 subjects. If we are going to find the center or the middle of the 10 grades, then we can find that the average is 94. So this is the average. So we can also say that this average grade represents the 10 grades or the 10 quarter grades of Anna. So we have here another example. Let's say we have here the height of members of a circle of friends in centimeters. So for example, this is a group of friends. There are 7 members in a group of friends, and their heights are given and measured in centimeters. So you have there 168 centimeters, 174, 154, 159, 173, 158, 115, and 157 centimeters. Now we're going to find the average height of a member of this group of friends. So what would be the average height of a member of a group of friends? So to do this, we simply add their heights. So 168 plus 174 plus 154 plus 159 plus 173 plus 158 plus 157 divided by 7, because there are 7 friends. And we get the average as 163.2 or 163 and 2/10 centimeters. So we can say that a member of a circle of this group of friends has a height of 163.2 centimeters. So we can say that this height represents the heights of the members of this group of friends. So that is the average. So as we define the word average, this is the middle value. It is the central point, the central value of a set of values. So another example, the daily income of a fish vendor in pesos. Daily income of a fish vendor in pesos. So we have here from day 1 up to day 8. So we have here 1,550, 1,650, 1,000 in day 3, 1,500 in day 4, 1,820 in day 5, 2,500 in day 6, 3,000 in day 7, and 2,400 in day 8. Now, if the question is, what is the average daily income of a fish vendor in pesos? So how do we do that? We simply add the daily income from the income of the fish vendor from day 1 up to day 8 and divide it by 8 because there are 8 days. So by doing that, we can get the result as 1,927 pesos and 50 centavos. So if a vendor is asked how much he earns for a day, so he might answer he is earning an average income for a day for about 1,927 pesos and 50 centavos. So this amount represents the income of a fish vendor every day. So since this is the middle or the central or the center of this set of values. So if your father is a fish vendor and he is asked how much does your father earn for a day? So of course, you might not answer these values because these are different values from day 1 and day 8. You just get the average from day 1 to day 8 and get the average, of course. And you will say that maybe, and you will say, for example, that your father earns 1,927 pesos and 50 centavos for a day. So that is just an example. Okay, another one is the average and the mean. So the most widely used method of calculating an average is the mean. So in statistics and probability, when we talk about average, we are also talking about the mean. So they are synonymous. These words are synonymous because when we say mean, we are taking the average, or when we say average, we're taking the mean. When the term average is used in a mathematical sense, it usually refers to the mean, especially when no other information is given. So it is understood that when we take the average, we are taking the mean. So let's take, for example, the number of spots in a die. So consider rolling a die. What would be the average value of the outcomes obtained? So when you roll a die, what is the average value of the outcomes obtained? So we are dealing with the mean or the average. So to do that, here is our solution. First, you're going to list to determine the sample space. Of course, we already know that the possible outcomes of rolling a die when rolling a die is 1, 2, 3, 4, 5, 6. So these are the number of spots that you might get when you roll a die. So to get the average value of the outcomes, we simply add the possible outcomes. So we add 1 plus 2 plus 3 plus 4 plus 5 plus 6 and divide it by the total number of outcomes. So since there are 6 possible outcomes, we divide it by 6. So by doing that, we get 21 out of 6 or 21, 6. So we can also simplify this by dividing 21 by 6. And we get 3 and 5 tenths. So what does 3 and 5 tenths means? So when you continue rolling a die many times, the average outcome that would appear is 3 and 5 tenths. Of course, there is no 3 and 5 tenths in the die. You cannot find any spot which is labeled as 3 and 5 tenths. This is just a theoretical mean. So this is just theoretical mean. Since we are dealing with average, the answer would be in decimal form. So since we are dealing with average, we may not get away with the decimal form. So that's why we have here 3 and 5 tenths. So this is the mean of the random variable or the mean of the probability distribution. Next one, example number 2 is the breeds of dog. So your friend has 5 different breeds of dog. He measured the heights of the dogs in millimeters. The heights are measured at the shoulders of each dog. So illustrate the mean and variance of the heights. So the heights of the dogs are measured at their shoulders. So first, the first dog has a height of 600 millimeters. The second dog measures 460 millimeters. The third dog measures 170 millimeters. The fourth dog measures 420 millimeters. And the fifth dog measures 300 millimeters. So we're going to illustrate the mean and variance of the heights. So to do that, we just simply add their heights and divide it by 5 since we have 5 dogs here. So we have 5 dogs. So we're going to add 600 plus 460 plus 420 plus 300 plus 170 divided by 5, we get 390 millimeters. So this is the average height of the breeds of dog. So we can say that a breed of a dog has an average height of 390 millimeters. So a certain breed of dog measures 390 millimeters. So the height is 390 millimeters. It represents the height of the 5 dogs. So 390 millimeters is found between or in the middle. So if this is 400, then 390 is located in here. So if you have noticed, the mean is found in the center of the set of values. So this is the mean or the average. So to get the variance, we will calculate each dog's height difference from the mean. So we're done with taking the mean. This time we will take the variance. So we have here a table. On the first column, we have here the dog's height or the random variable, and we have here the mean. For dog's height, we have here the first one is 600. We have another one here. The mean is common to all because we only have one mean. So we have here the dog's height. So we're going to get the height difference from the mean. How to do that? So we simply subtract the height of the dog from the mean. So from the mean, take note, difference from the mean. We're going to subtract 600 minus 290 is equal to 210. So 460 minus 390 is equal to 70. 170 minus 390 is negative 220. 420 minus 390 is equal to 30. And 300 minus 390 is equal to negative 90. So these are the results when we get the difference of each dog's height from the mean. So next, after getting the difference of the mean, we are going to square each difference and then average the results. So we're going to get the square of each difference from the mean. So example, 210 squared. So this means 210 times 210, that would be equal to 44,100. You can check that using the calculator. So 70 squared 70 times 70 squared, so that is equal to 4,900. Negative 220 times negative 220 is equal to 48,400. 30 times 30 or 30 squared is equal to 900. Negative 90 squared or negative 90 times negative 90 is equal to 8,100. So these are the results when we square each difference from the mean. Now what we are going to do with these squares? So we're going to get the average. So take the average. How? So we simply add the result. Add the result. So remember the how to get the average. We're going to get the average. You're going to get the sum and divide it by 5 since we have 5 results here. So 1, 2, 3, 4, 5. So add 44,100 plus 4,900 plus 48,400 plus 900 plus 8,100. Then divide it by 5. So we have here the variance, which is equal to 21,280. So that is the variance. Next, out of the variance, we can get the standard deviation. So how to get the standard deviation? Just get the square root of the variance. So if this is the variance, 21,280, get the square root of 21,280. So if you have calculators in your respective homes, or you can use your cell phone, so just do it. So get the square root of this, of the variance. We get 145 and 87 millimeters, or this is approximately equal to 146 millimeters. So this is our standard deviation. So that is our variance and standard deviation. Later, in the next lesson, we will discuss what is variance and what is standard deviation. So the standard deviation is useful for us to understand how the heights differ from each other. Now we can show which heights are within one standard deviation, or 146 millimeters from the mean. So, meaning, standard deviation means how is the distance. The standard deviation tells us the distance between the heights of the dogs from the mean. If the height of if the mean is 390 millimeters, then the distance of each dog's height from the mean is 146 millimeters. So the standard deviation simply means the distance from the mean. So each value, each x, the distance of each x from the mean. So we can say it is the example, gaano siya antad sa mean natin. Since the mean is found at the center, so what is the distance? The standard deviation tells us its distance from the mean. So I hope you get that. So using the standard deviation, we have a standard way of knowing what is normal and what is large or small. Example, if we have 390 millimeters as the mean, this is the mean from our previous solving or computation. If 390 is the mean, 390 millimeters is the mean, then we can say that this dog's height, 600, is too large or too far from the mean. We can also say that 460 is nearest to the mean. Same with 170, 420, or 300. So we can say it's another way of um, telling if the if the heights of the dogs are too far or too large or too small from the mean. So if another one, if our mean is 390 millimeters and the standard deviation is 146 millimeters, since this is the distance of each dog's height, then we can say that the heights are too large, or the distance from each from the dog's height, the distance of dog's height from the mean is too large because this is too far. 146 is a large number. So the concept we have here, the variance of a random variable displays the variability or the dispersions of the random variables. It shows the distance of a random variable from its mean. So variance and standard deviation are measures of dispersion. When we say dispersion, it is the coverage or how dispersed, how scattered the values are. Example, let's take for example COVID-19. So how spread COVID-19 is. So we can say that it is really a widespread because it reaches globally. So although it is already a pandemic, meaning it reaches um, globally or worldwide. So the dispersion is too wide. So this variance is also the dispersion, or it tells us the dispersion or the variability, or the difference of each height of the dog. So it also shows the distance of a random variable from its mean. So to illustrate the idea of the mean and the variance and standard deviation, let's have here example number 3. So illustrate the mean and variance of the given histogram. When we say illustrate, you're going to show, to demonstrate, or to prove, or to discuss the mean and variance of the given histogram. So we have here the given histogram. So we have here, it is placed on the Cartesian plane. So under the x-axis, or in the horizontal line, you have here the values of x, such as 1, 2, 3, 4, 5, and 6. And on the y-axis, you have here the probabilities. Notice that each of them has equal probabilities. Now, how do we find the mean? So first, we're going to illustrate the mean. So simply, in our previous activity, we simply add the values of x. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. And divided by 6, we get 3 and 5 tenths. So the mean is 3 and 5 tenths. And it can be found here in the middle of these values, in the middle of these 6 values. So since they have the same probabilities, we can also say that the mean is found here in the center. Next, to determine the variance or the spread of elements away from the mean, we will have the following procedure. So to be able to determine the spread of the elements, or we are talking with the dispersion, when we are talking with the dispersion or spread, we're talking about the variance and the standard deviation. So how do we get that? So simply we will follow the procedure here. So since we are comparing two elements, this time 1, we will compare 1 and 3. This is the left side, and this is the right side. We are also comparing 4 and 6. So again, 1 and 3 are found on the left side of the mean, This is the mean. So 1 and 3 are found on the left side of the mean. Our mean is here, which is 3.5. So it is marked with arrow. And 4 and 5 are found on the right side of the mean. So here the mean will be doubled. That is why we have here 7, which is the new mean. So 3.5 times 3.5 is equal to 7. So that is why we have here the new mean. Now, by comparing the two elements, we will add, from the left side, we will add 1 plus 3. So 1 plus 3 is equal to 4. That's why we have here a value of 4. And on the left side, we will add 4 plus 6. So again, we are determining the spread of the elements. So that is why we are doing this procedure. So 4 plus 6, that is equal to 10. That is why we have here 10. Now, since we have here the new mean, which is 7, we're going to determine the distance of the elements from the mean. By doing that, we're going to subtract 4 from 7. So 7 minus 4, 7 minus 4, we have 3. This is on the left side of the mean. And 10 minus 7, we have here 3 also. If we're talking about distance, the answer would always be positive. So, by doing that, we have arrived at the values of 3. So, what does 3 means? So, the distance of the element from the mean in either direction, whether left side or right side of the elements, either direction is 3, which describes the spread of the elements in the observation. So, you have noticed that if we're trying to determine how spread the values are from the mean, meaning we have here 3. So in any direction, so if you have noticed, the distance are equal. So we have here 3. As the spread or the distance of the elements from the mean, it's either on the left side or on the right side. So I hope you get that. So this is the idea of variance and standard deviation. So we have here another example for you to understand how to illustrate the mean and variance better. So again, we're going to illustrate the mean and variance of the given histogram. So you have noticed here, we have here the mean, the value of x, I mean. So these are the values of x. So we have here 2, 3, 4, 5, 7, 8, 9, and 10. So if you're going to get the mean, we just simply add this value. So 2 plus 3 plus 4 plus 5 plus 7 plus 8 plus 9 and plus 10. We're going to get 48 and divide it by 8. So since we have 8 histograms here, so the result, the average is 6. And it can be found in the middle. So this is our mean. So observe that this is our mean. So it is also clear that it can be found in the center of the given values of x. Now, how do we find the variance, or how spread are the elements in the given histogram? So we're going to follow this procedure. So we're going to double, since it has equal probabilities on the right side and on the left side. So we're going to double the mean to get a new mean. So 6 times 2, 6 times 2, we have 12. So this is the new mean. Now we're going to determine the distance from the left side and on the distance from the right side from the mean. So we have 2 and 5 on the left. So we're going to add 2 and 5. 2 plus 5, we have 7. And on the right side, we have 7 and 10. We will get 7 and 10 on the right side. So simply add these two values and we get 17. So from this part, we have a new mean. So 12 is the new mean. So what shall we do to get the distance of the elements from the mean? So we're going to subtract 12 and 7 to get the distance from the mean. So 12 minus 7, 12 minus 7, we get 5. And on the right side, we do the same thing. So 17 minus 12, so it is 5. So if it is negative or positive, it is still positive because distance is the absolute value. Okay, we're going to determine the absolute value. So from here, we have here 5. We arrived at 5, meaning the distance of the elements, the distance of these elements, this histogram from the mean is given by 5. So observe that they have equal distance in any direction, which is either in left or in right. So that this is the idea of the variance and standard deviation. So I hope you get the idea. So this implies that the distance of the element from the mean in either direction is 5, which describes the spread of the elements in the observation. So again, when we talk about the spread, it is the coverage of the elements of how gaano siya kalapta, anong distance niya sa mean, what is the distance from the mean. So this time, we're going to compare the variance and standard deviation of the two distributions. So first, we have here, so you will label this as letter A. Okay, so to get the variance, of course, if we first look for the mean. So if you have noticed, the values are symmetrical on the x-axis, so we can easily determine the mean, which is the center, or the middle, which is 6. So we can check that by simply adding the values of x, such as 3. 3 plus 5 plus 7 plus 9 is equal to 24 divided by 4, since we have 4 values here, so the average is equal to 6. So the mean is 6. So now we will compare the two values from the left side of the mean, which is 3 and 5, and on the right side of the mean we have 7 and 9. So simply add the two. So 3 plus 5, we have here 8, and on the right side 7 plus 9, we have here 16. So next we are going to get the average, or to get the mean. So 8 plus 16, we have 24 divided by 2, since we have only two values, so therefore the average is 12. And to get the distance of the element from the mean, simply subtract 12 minus 8, we have 4. And on the right side, do the same thing, 16 minus 12 is 4. So if you have noticed, the distance of the element from the mean in any direction is either on the left side or on the right side of the mean is 4. So this is the distance of the element from the mean, or the variance. On the next illustration and in the next distribution, we label it letter B. We're going to determine first the mean. So the values are symmetrical on the x-axis, so our mean is the center, which is also 6. So you can check that by adding the values, such as 2, 2 plus 3 plus 4 plus 5 plus 7 plus 8 plus 9 and plus 10, you get 48. Divided by 8, so because we have 8 values here, the result is 6. So the mean is 6. Now we will compare two values. This time on the left side of the mean, we will get 2. We will compare 2 and 4. And on the right side, we have 8 and 10. So simply add the two values on the left side of the mean. So 2 plus 4 is 6. And on the left side, on the right side of the mean, we have 8 plus 10, we have 18. Next is we're going to get the average of 16 and 18. So 6 plus 18 is 24, divided by 2 because we only have two values. So the average or the mean is 12. This is the new mean. So to get the distance of the element from the mean, so simply subtract. 12 minus 6 is 6. And on the right side, do the same thing. 18 minus 12, we have 6. So if you have noticed, the distance from the mean on the left side and also on the right side of the mean is equal to 6. Now, how do we compare the two values? Which illustration do you think show less spread out? So we can answer it by simply observing the two distribution. So in letter A, the distance or the dispersion is less because it's spread by only 4 in any direction. See, so the distance is only 4, which is narrow, meaning the distance of the element from the mean is closer to the mean, which is which is closer to the mean. So this means that the variance is narrow and concentrated around the mean. So narrow means makitid siya, meaning medyo malapit siya sa ato ni mean. While in letter B, in distribution letter B, it shows the farthest spread out because 6 is greater than 4, meaning it is spread out. Now we can say that we have the farthest spread out. It is farther than compared to letter A because the element dispersed 6 away from the mean. So which means that the element is farther or malayo siya, medyo maantad siya. Maantad ang distansya niya from the means because we have 6 spread out away from the mean. So by comparing, we can say that letter B has a large spread out or farther spread out compared to letter A because 6 variance is greater than 4 variance. So by that, we can say that by using variance and standard deviation, we can determine which is farthest from the mean or which is narrow from the mean. So if we have a small value of standard deviation or variance means that the dispersion of the random variable is narrowly concentrated around the mean, meaning the distance of the element is closer to the mean. So here we have in letter A, which has a small value compared to letter B. A large value of standard deviation or variance means that the distribution is spread out, meaning maantad siya, malayo siya gawa sa aton nga mean, with some possibility of observing values at some distance from the mean. So our large value here, comparing the two, so in letter B, we have a large value, meaning that the distribution is spread out compared to letter A because the dispersion in letter A is narrowly concentrated around the mean. So that is how you compare the variance and standard deviation of the two distributions. So I hope you get that. That's it. So let's have here the activity proper. In activity proper, so again, be mindful of the general directions. So we have here exercise 1. The following are the number of computers sold in 4 consecutive days. Illustrate the mean and variance. So just like we did in the previous discussions, we are going to illustrate the mean and variance and answer the questions that follow. So answer number 1, how do you find the mean? How about the variance? Number 2, to show the process where you illustrate the variance and the standard deviation. So it's up to you or how you are going to show the process. Exercise 2, compare the variance and standard deviation of the two figures provided. So when you are comparing, you have to determine first the variance and the standard deviation. Of course, you're going to determine also the mean. And you have to state what have you noticed about the variance and standard deviation of these two figures. And of course, in your journal notebook, do not forget to write your reflections on the head, heart, bin, and bag, just like with what you are doing every at the end of every lesson that we have. So that's all for this lesson. I hope you have learned a lot. You can still review, play, and pause this video lesson if you have difficulties in understanding. And for your comments, feedbacks, please do not hesitate to write your suggestions and your comments for this video lesson so that I can improve this video lesson for you.